Hello, my lovely pre-calculusers. It's time for families of graphs. This is going to enlarge on what I talked about before about reflections. And in order to understand what's going on, you're going to want to understand the relationship between the parent graph and another graph in that family. So here are the graphs that you need to be familiar with. Some of them you are familiar with. The constant function will be y equals 0. It's the same as the x-axis. Identity function, y equals x. So y equals 1x. It's a line with a slope of 1, y-intercept of 0, and basically y is whatever x is. Polynomial functions, if they're even, they're going to be essentially like this. So x squared looks like this. X to the fourth also looks like this, although a little tighter because it goes up faster. But they're parabolas. X cubed and all of the evens are going to go more like this. So you're probably not so familiar with this shape. Get familiar with it. You need to be able to recognize it. Square root function like this. Remember, it's not defined over here. Absolute value function you are familiar with. Greatest integer. This is that step function, right? Where it's the greatest integer less than or equal to your input. And it goes like this. We will be using this. And the rational. So this is 1 over x. And it always goes like this. It never touches the y-axis. It never touches the x-axis. And yeah, so that's the rational function. So the two kinds of transformations that we'll talk about are reflections, flipping the graph over the line, and translations. Oh, hey, and dilations. All right, translations which move it, dilation which expand or compress. And I'm going to give you some hints as to how you can remember what does what a little later. Graph x cubed and negative x cubed and describe how they are related. So here is my f of x. This is going to be x cubed. And that basically goes like this. It always goes through 1, 1, and negative 1, negative 1. That can kind of help you guide it. So that's x cubed. And you can put it in your calculator. Now, negative x cubed, and you should put this in your calculator, I just don't have a calculator handy. What that will do is it will reflect it. So instead of going through 1, 1, it'll go through 1, negative 1. Instead of going through negative 1, negative 1, it goes through negative 1, positive 1. So what this does is it, g of x reflects f of x over the x-axis. It just takes this and flips it. So in this case, actually, reflecting it over the x-axis, reflecting it over the y-axis look the same, but this is reflecting over the x-axis. So here are the rules. And they basically break down into two kinds of things. If something happens, if something is done before the function is applied, you're talking about a horizontal change. If it happens after the function is applied or outside the parentheses, it's going to be a vertical change. So you might want to make a note of that. Inside parentheses, or before the function is applied, will be a horizontal change, and it always it tends to be the opposite of what you expect. Op of expect. If it happens outside the parentheses, or that is to say after the function is applied, it's going to be a vertical change, and it's usually going to be what you'd expect to happen. So it's just a way to remember what's going to happen. So if you have a negative outside the parentheses, outside the function, it happens after the function is applied, that's going to be a vertical reflection. It's going to be reflected over the x-axis. It will flip upside down. Upside down. Anyway, if the negative is inside, if it happens before the function is applied, you're looking at a horizontal reflection. It reflects over the y-axis. You actually can't tell with a function like this, but it would be flipped this way. Kind of hard to see in 2 dimensions, but that's the deal. Translations, if you are adding or subtracting outside, then you're going to move it vertically and you're going to move it the way you'd expect to. If you're adding a positive, the function goes up. If you're subtracting, the function goes down. If you're adding or subtracting inside the parentheses before the function gets applied, then you're moving it horizontally, and it tends to be the opposite way of what you expect. So if you're adding a positive, you're actually going to shift it to the left, into the negatives. If you're subtracting, you're going to move it into the right, into the positives. This is really, understanding this and remembering it makes graphing so much easier. You're not focused on the calculator, you're not always picking points, you can just say, oh, this is what should happen. So we're going to use the parent graph x cubed, which is that one I drew before, to sketch the graph of each function. So x cubed minus 1, we're subtracting, we're cubing first and then subtracting, so this is going to be a vertical shift. And it's a negative, so we're going to go down. So basically we're going to take this shape, but instead, and I always work from the middle, so instead of going through 0, 0, it'll go through 0, negative 1. And it will go like this. Basically, you know what cubing is, so 1 cubed is 1, 2 cubed is 8, so it's usually not even going to show up on the graph. And then like this. And there we go, that's x cubed minus 1 without a calculator. X minus 1 cubed, so this is happening inside the parentheses before you're cubing. That's a horizontal shift. Remember, it's opposite of what you think, so it's going to go right 1, that is into the positives. So instead of going through 0, 0, it goes through 0, 1. And up like so, and down like so. There you go. You can put these together. So this is a horizontal shift, right 1, and then a vertical shift up 3. So instead of going through 0, 0 as the middle, it will shift to the right 1, and then it'll go up through 3. So the center point, the place that it kind of changes direction, is at 1, 3. And then I just draw the shape. This one I can actually do 1, 2, 3, 4, 5, 6, 7, 8. So that's where it will actually go through the line. There you go. And you can put it in the calculator. You can always put it in the calculator. But you need to know what it does and be able to describe what it does and why, based on knowing these rules. Dilations. It's the same sort of thing about horizontal and vertical. If you are multiplying outside the parentheses after the function is applied, then you've got a vertical change, and it's basically going to happen the way you think. The bigger the number, the taller the graph is. So these tighter in this one here, this is multiplied by a number that's larger than 1. If you're multiplying by something that's less than 1, it will be compressed vertically. So this, you can think of this as getting taller, and this is being sort of smushed, or shorter, but I think of it as smushed. It's pushed downward, so compressed vertically. If you're multiplying inside the parentheses, it's a horizontal change, and it's the opposite of what you'd expect. Compressing horizontally makes it narrower. So if you're multiplying by a number that's greater than 1, you're making it narrower. Expanding, you're making it wider. Multiplying by a number that's less, between 0 and 1, makes it wider. And this is also gone over in the textbook with nice color drawings, so take a look at that. Okay, use the graph to sketch each related function. So the parent function is x cubed, that's already graphed here. Y equals x cubed plus 2. When 2 is added, the graph of the parent function moves up 2 units. We just did one like this. It just means take this identifiable point, move it up 2. And then the rest of it just kind of shifts along with it. There you go. That's all you got to do. Now it's time for greatest integer function. I know how everybody loves that. So this is greatest integer function, right? The greatest integer less than or equal to your input. Multiplying by 3 outside, so it's a vertical change. This is actually one of the very few functions where you can see the difference between a vertical and horizontal. This will be a vertical change, and it will expand vertically. because this is bigger than 1. What happens is the 1 at 0, 0 stays there, and then you jump up 3 to get to the next one, and then another 3 to get to the next one. The width of each is still the same as it used to be, but the jump in between them is longer. And obviously, you could pick some points, right? If x is 0, 1/2, 1, 1.5, 2, then greatest integer less than or equal to 0 is 0, 3 times 0 is 0. Greatest integer less than or equal to 1/2 is 0, 3 times 0 is 0. Greatest integer less than or equal to 1 is 1, 3 times 1 is 3. Greatest integer less than or equal to 1.5 is 1, 3 times 1 is 3. Greatest integer less than or equal to 2 is 2, 2 times 3 is 6. So the individual thing stays the same, but when it changes level, it jumps up by 3 more. Here the parent function is absolute value of x. We are multiplying it outside, so that's a vertical change, and by a number between 0 and 1, so that means it's compressed, it's smushed. So instead of going up 1 each time, it only goes up 1/2 each time. And again, yes, you can absolutely put this in your calculators, totally fine, but you need to also know why it happens that way. And you should be able to sketch them freehand. X squared. This one is a funky one because they're putting a couple things together. So first, the squared is applied and then you subtract 4. So this is actually outside the square function. It's happening afterwards. So vertical shift down 4, which would take it down here. I'm going to sketch this, but since I'm then going to change something, don't don't make it permanent. So this is what it would look like when you shifted it down 4. Oops, sorry, it needs to be a little steeper. If you shifted it down 4, it would look like this. But then, taking the absolute value means whatever is negative needs to be positive. So instead of this being 0, -4, it's 0, +4. So this being -1, -3, it's -1, +3. And like that. Same here. Yeah. And there you go, so you got this W shape. Last thing, write the equation. So they're only giving you the graph and they're expecting you to figure out the equation. So you can of course try a couple things in the calculator to see what worked, but let's get a theory. So here's the parent function. What's going on here? It's shifted up 1. So it's a vertical, which means it happens after you take the cube root. And it's up 1. So there we go. That's your g of x. This one, see, the thing is, this is turned over and then shifted. And it's shifted to the right, so it's got to happen inside. So a shift, I'm thinking about how best to do this because we have to reflect and shift. So what it actually is, before you reflected around the y-axis, it would have gone through here, right? So it was shifted left. So that means x plus 1 in the cube root. And then made negative to flip it around the y-axis. It flips it around the x-axis, doesn't it? Negative here. So that was a mess, and I wouldn't rely on it. So what would I do? I'd go to the calculator. So you guys try this out. See if it gives you the right graph. If it doesn't give you the right graph, change it. Come back to me and tell me what this ought to be. This one, however, is pretty straightforward. It's left 2, up 1. So that means this is going to go inside the parentheses. No, sorry. This is going to go inside the parentheses. It'll be x plus 2 cube root. This will go outside the parentheses. So up 1, and that's your k of x. I do know how to do this. I'm suddenly having like a brain freeze where it's not working that well. Oh! You know what's even better here? Sorry about that. flipping it around the y-axis is confusing, but flipping it around the x-axis is not. It moves to the right one, you take the cube root, and then you negate it, and it just flips it upside down. That will work, and that's your h of x. Check me in the calculator and tell me whether I'm right or not. All right, see you tomorrow.